right, today we're learning section 6.7, probability and odds. We're on page 306 in our books. All right, so in this first slide, you really, you want to write all that down? No. You don't have to write it down. Basically, what the definitions are saying is, it's basically just talking about what these different terms mean. So the results of an experiment, so say you have a number cube in your hand and you're rolling the number cube. Whatever number comes that you rolled, that's an outcome, okay? An event is an outcome or a collection of outcomes like rolling a 1 or an odd number, okay? Now, a favorable outcome is when you get the outcome that you were looking for. So if you're looking to roll an odd number and you do, then that's a favorable outcome. And then overall, the probability means it's the likelihood that an event is going to occur. Now, probability can be good or bad. If I said, in the last class I used the example of jumping off of a cliff into the water. If I was jumping off of a cliff into the water, and the probability that I would get seriously injured is 0.75 or 75%. Should I jump? Yeah. No, because that's a pretty high probability that I'm going to get hurt. Well, what if the probability was 0.1 or 10%? I'd probably jump. I mean, it depends, like, if I'm in, like Hawaii or something, or, it's like a once-in-a-lifetime thing, I'd probably take the risk. Okay, but probability, guys, actually we use probability every day and we probably don't even think about it that way. But anytime we're looking at, what is the likelihood that if I say this to my teacher, they're going to write me up? Some teachers write referrals a little easier than others, so probability of receiving a referral in one class might be higher than in another. Do you kind of see where I'm going with this? Okay, so that's probability. All right, so here's what you need to know. Go ahead and write this in your notes, the first thing that you need to write in your notes. The probability that an event happens. Now, what you see in parentheses is going to change depending on what you're looking for. Rolling an even number, rolling an odd number, rolling a 3 or a 4. That, whatever you're looking to get, or to, whatever the favorable outcome is, that goes in parentheses. And then you divide favorable outcomes by possible outcomes. So go ahead and write that down. All right, so let's look at this first example. It says, suppose you roll a number cube. What is the probability that you roll an even number? Well, in a number cube, how many numbers are there? 6. Okay, so that's something that you just have to know. That's basically assumed. Like, how many cards are in a deck of cards? 52, not including the joker. Okay, so 52 cards are in a deck of cards. With probability, a lot of times you have to know those numbers that are assumed. Okay, so with a number cube, you have to know that there are 6 sides or 6 possible numbers. So what is the probability that you roll an even number? All right, so here's the event. Probability, let's see, there it is. Probability, sorry, I'm pulling up my slide. P, and then of an even number. So I'm looking for an even number, so that's why that goes in parentheses. And how many even numbers are in 1 through 6? 3. So favorable over total, and then you reduce it to 1/2. Now, I prefer that you write all of your probability in decimal form, so that would be 0.5. Now, if you were to say 1/2 on a problem like this, I'd be fine with it. But as a rule, just overall, it makes it easier if you just write all of your probabilities as decimals. Okay? Okay, so now, what is the probability that you roll an odd number? All right, so go ahead and set it up. P, parentheses, what would you write in parentheses? What's the... Okay, yes. I meant for that to be like a, rhetorical question. But yes, probability of odd. Now write your fraction, don't say it out loud, and then we'll talk about the answer in a second. Okay, so how many odd numbers are 1 through 6? 3. So again, it's 3 over 6, which is 1/2. So what's your decimal value? 0.5. All right, let's do one more. suppose you roll a number cube. What is the probability that you roll a 4? All right, so go ahead and set that up. What'd you put in parentheses? 4. Probability of a 4 equals, how many 4s are there? 1 over 6. All right, did you get 1/6? Good. What is the probability that you would roll a number greater than 1? So now in parentheses, can you just say a 1? No, because then you're telling me probability of rolling a 1. So in parentheses, you have to say probability greater than 1, okay, because that's what you're looking for. Probability that it's greater than 1. So go ahead and create your fraction. All right, so how many of them are greater than 1? 5 over 6. And I forgot on the last one, but make sure you write it as a decimal, 0.83. And it is, the 3 is repeating, so I just go 3, 3, and then I round to the nearest hundred, so 0.83.
Last one would have been 0.17.
Okay, 17. Okay, yeah, that's right, 1 over 6. All right, 0.83. Now, if you said 0.833 repeating, that would be fine. I wouldn't take off for that. All right, so now let's talk about experimental probability. It's pretty much the same thing because you can think of successes as being favorable, right? And you can think of trials as being the total number of, times that, an event happened. So possible events or possible outcomes. So technically it's the same thing, except now, an experiment is when you what? What is an experiment? You're just randomly trying things out. Now, in your book, it's going to give you a lot of sports examples, basketball, baseball, batting practice, shooting free throws. You'll see that common kind of theme popping up. So let's look at one of them. Okay, miniature golf. It says a miniature golf course offers a free game to golfers who make a hole-in-one on the last hole. Last week, 44 out of 256 golfers made a hole-in-one. Find the experimental probability that a golfer makes a hole-in-one. So, probability of a what?
A hole-in-one.
A probability of a hole-in-one. Okay. How many made it? What's the successes? 44. What's the number of trials? 256. Okay. So now I take that fraction and I change it to a decimal. 0.17. Okay, so now I want you to try one. Very similar, pretty much the exact same thing, except just different numbers. All right, so probability that you get a hole-in-one, all right, equals, what's the successes?
37.
What's the attempts?
44.
All right, and then when I change it to a decimal, okay, it's like a really long, repeating decimal, so I just round to the nearest hundredth, 0.13. All right, or 13%. That's a very low percentage, isn't it? Yeah, because getting a hole-in-one is pretty hard, even with mini golf. I don't think I've ever, no, maybe I have gotten one. Okay. All right, let's, yeah, very good. All right, so let's go ahead and find experimental probability for this problem. Go ahead and set it up and see if you can find the answer. Again, round to the nearest hundredth if you need to. All right, so probability that the next student plays sports. Okay, well, how many play sports? 15. Over how many total? 45. So that's going to be 1/3 or 0.33. All right, did you get it? Pretty easy so far? Y'all doing okay? All right, moving on to interpreting probabilities. Now, you don't have to write any of this down. Okay, I just want to kind of go over it. All right, so if your probability is 0, okay, probability that you win the lottery is pretty close to 0, right? So these are more unlikely, meaning it's not going to happen. Now that could be good or bad. If I say, what is the likelihood that you get injured jumping off a cliff, you want it to be a low probability, right? You want to get hurt. But what if I said probability that you win $1 million? You want it to be a high probability, right? Yeah, of course. Anybody wants to win $1 million unless they're lying. Okay, so low and high probability. It's anywhere from 0 to 1. Okay, the likelihood that something is going to happen. All right, moving into, I pressed the wrong button. Hold on. Come on. All right, now moving into the next. Okay, using probabilities to make a prediction. All right, so now let's look at the basketball example. Today you attempted 50 free throws and made 32 of them. All right, so I have to find probability there and then use the experimental probability to predict how many free throws you will make tomorrow if you shoot 75. So probability that I'll make a free throw. How many did I make today?
33.
How many did I try? 50. So go ahead and find the decimal value of that. And what is it?
0.64.
0.64. 0.64. So once you have that decimal value, take the decimal value and multiply it by the predicted number that you're going to shoot tomorrow, which is 75. And that will give you, if you make the same basically proportion of free throws that you made today, how many free throws will you make tomorrow? 48. 48 made. All right, so now I want you to try this one. It's not going to work out evenly, so round to the nearest hundredth because you can't make like half of a free throw. That doesn't count. Okay, so just go ahead and round as needed and find the experimental probability. Okay, so you should have done probability of free throw made, 50, oops, hold on. Okay, just messed up, but we're going to keep going. We're just going to go with it. 50 over 75 equals 0.67, and you should have multiplied that by 100 to get about 67 made. Did you get that? Okay, very good. All right, so now let's talk about odds, okay? You do need to write these two fractions or formulas down. All right, odds in favor and odds against. Now, do you see anywhere in that fraction where it gives you a total? It says divide by the total? No. If you're looking for odds in favor, you divide favorable over unfavorable, which together give you the total, but you don't divide by the total. Odds against are unfavorable over favorable. So the way you can remember it is whatever it's looking for, that goes on top. If it's looking for against, that goes on top. Okay? Odds in favor or odds against.
No, I just yawned.
All right, so let's see what this looks like. It says, suppose you randomly choose a number between 1 and 20. What are the odds in favor of choosing a prime number? So I have to figure out how many prime numbers are between 1 and 20. All right, well, let's count. Is 1 a prime number?
No.
So 2,
Yes.
3,
Yes.
5,
Yes.
7,
Yes.
9.
No.
Okay, 11, see if you're paying attention. 13, 17, 19. Okay, so odds in favor, there are 8 prime numbers that would be favorable. So probability that it's prime equals favorable over total. Is that the formula?
No.
Favorable over
Unfavorable.
unfavorable. Well, how would I figure out unfavorable?
20 minus 8.
Why did you do 20 minus 8?
Because that's the total.
Because that's the total. You choose a number between 1 and 20, so that tells you how many total numbers are there. 20. So if 8 of them are favorable, how many are unfavorable? 12. Do you see how we did that? We just subtracted. So this would be 8 over 12 equals, and then I just change it to my decimal value, which it is a repeating decimal, so I just round to the nearest hundredth. All right, so now let's look at B. What are the odds against choosing a prime number? Okay, so look at your formula. Try to figure this one out and find your decimal value. All right, so probability that it's not prime now. Okay, so it's going to be against the prime numbers. So how many are not prime? 12 over how many are? 8. So did you get 1.5? All right, good job. All right, last but not least, letter C. What are the odds in favor of choosing a number divisible by 5? So I want you to try to solve this one. All right, so probability that it's divisible by 5. What does it mean to be divisible by 5? Like it goes into it evenly, right? Okay, so odds in favor. So how many numbers does between 1 and 20 does 5 go into? 4 out of. Okay, so now if there's there's 4 numbers that are favorable, how many are unfavorable?
Oh my goodness.
16. 16, not 20. It's favorable over unfavorable, which is going to be 0.25. All right, see, it's very easy to do. Actually, last hour, I made that mistake too, so don't feel bad. But remember, it's favorable over unfavorable, or the switch, it's not over total. Okay, not when you're finding odds in favor or against. And if you understand that, that's everything you need to know for 6.7.